Okay, our next presentation, unfortunately, she comes from the East Coast at Oak Ridge National Lab. Suzanne Parete Koon, unfortunately, was not able to make it, and she sent us a video instead. This is the problems with virtual where time zones matter. So give me 1 sec, and I'll get this video up.
Good afternoon, everyone. I'm Dr. Suzanne Parete Koon of the Oak Ridge Leadership Computing Facility, where I work as a high-performance computing engineer. I'm also the Workforce Development and Retention Action Group lead for the Department of Energy Exascale Computing Project Broadening Participation Initiative. So today I'm going to use the example of the U.S. Department of Energy National Labs computing workforce challenges as sort of a microcosm of the challenges facing all of us in computing. And I'll talk about the Exascale Computing Project's Broadening Participation Initiative and its efforts to try to combat and meet some of those workforce challenges. I'd like to thank all of my collaborators in the Exascale Computing Project Broadening Participation Initiative who have helped contribute to this body of knowledge that I'm about to present. So I'll start with sort of the good news first. This plot is from the Talby survey. Talby survey is a Computer Research Association survey that surveys about 171 departments or programs in computer science and engineering. It's been running since 1951. So here I'm showing the trend in bachelor's degrees in computer science and engineering since 1995. And the really excellent news here is that the trend since 2009 has been increasing rapidly. Don't know if we could know what this turnover means since these 2 years are the pandemic years, but overall, this is really good news. So we have about 35,000 new bachelor's degrees in computer science or computer engineering being produced. That's great news, but according to the US Bureau of Labor Statistics, we're adding about 100,000 new computing related jobs each year. Some of those require more than a bachelor's degree. And if you look at the Talby survey, you'll see that the number of masters and PhDs is sharply less than this, although it has been increasing as well over time. So I think the problem that probably faces all of us is that we have a lot more jobs coming into the market than we have qualified workers. Now, I'm going to use the United States Department of Energy National Labs computing to sort of illustrate how specialized computing challenges in the workforce are impacting us. And hopefully this example is also applicable to many other departments, or at least the sort of problems we're having. Just to give you an overview, the United States Department of Energy obviously is a US government agency. It has an office called the Advanced Scientific Computing Research Office. You'll hear me refer to it by its acronym, OSCAR. And OSCAR manages all of the computing resources in the 17 Department of Energy National Labs. So what this particular vein of the Department of Energy does is high performance computing. And in fact, it is the leading open science version of this in the world. So here I have a picture of the Frontier machine. It is the first open science exascale machine, meaning it can do 1 × 10⁻¹8 calculations per second. So that's a lot of floating point operations. With that power, you can get an unprecedented fidelity in simulations of nature. So what people do, hundreds of researchers apply for access to machines like this one. Here is the National Energy Research Scientific Computing machine Perlmutter. It's another example of these machines. There's also the Argonne National Lab has several of these machines. So access to these machines is based on merit. Generally, the PIs are probably academic professors and their students and postdocs. People from all over the world can get access, and you don't pay. It's based on several merit-based programs to get access to these machines. You can think of these machines sort of like you would think of the Webb telescope. It's a lab for science that is sort of unique, and it belongs to all of the people in the scientific community. The staff at the 17 national labs that generally deals with high performance computing includes computational science engineers, systems administrators, domain scientists, algorithm, people that work on software development, people that work on big data analysis, storage technologies. So it has a pretty broad span, and that set of people is somewhere over 2,000 people in the national labs. So that's just the size of the computing workforce. Oscar and computing is just one of the many scientific efforts in the Department of Energy programs. So the challenge of building these computational scientists and engineers that can enable this extreme scale computing is that they have to be extremely interdisciplinary. And this is probably not limited to high performance computing. I think all of us probably have needs that require some cross-cutting section of computational science disciplines, but our particular high performance and extreme scale computing engineers, the teams need to have a domain science, as well as algorithm development, applied mathematics, computer science, and software development. As high performance computing has headed towards the exascale, the amount of data produced in these simulations is quite large. So we need experts in big data science. And also, as machine learning has risen as a discipline, we need experts that are capable of machine learning and artificial intelligence. And one of the projects running on these machines probably needs all of this. And often those specialties are all in one person, or not all together, but in the teams, people will have several of these specialties individually. So it's pretty hard to build a computational science or engineer that has all of those cross-cutting things in one person, or even selections of them. There are two models of education. Usually people coming into these positions have at least a bachelor's degree and probably a master's or a PhD. PhDs are very sought after in computer science and engineering for these positions. So the two models are someone gets your traditional graduate degree in computer science and engineering. Usually it's in mathematics or algorithms or some sort of design of engineering. The other mode is generally someone gets a graduate degree in a domain science, and then they cross-cut to learn high-performance computing and computer science and engineering through the computer science engineering department in their university, or through courses in their domain science program that are designed for high-performance computing. There's actually a shortage of programs in the United States that develop people that can do high-performance computing and have this much interdisciplinary overlap. In 2014, the advisory council, called the Advanced Science Computing Advisory Council that advises Oscar, did a survey of the national labs and asked them for positions that they had in high demand. So you can see there's 8 national labs. These are a lot of sort of alphabet soup, but I give you a couple examples. This is Lawrence Berkeley National Lab, Oak Ridge National Lab, Argonne National Lab. You see a few others here, but just to give you sort of all these things ending in NL are national labs. And these are the 8 labs that deal most with high performance computing and computing in general. So these are the areas that the labs said were most difficult to fill. And you can see it's across the board of some of those interdisciplinary things I mentioned: advanced computing architectures, applied mathematics, computational science and simulation. Cybersecurity is a big one. A lot of data science type topics. Algorithms, so dynamic mesh algorithm, solvers would be in there. Many things related to high performance computing specifically, high performance storage, uncertainty quantification, and visualization and scientific data analysis. So the reason these are in demand is it normally takes about 100 days in an office of science, or like the open version of our national labs, to fill a position. And in the more national security focused labs, it will take 200 days, or twice that long. Compare that to industry. The averages that were reported in this newsletter were around 50 days. So it's harder to fill these positions for a couple of reasons that I'll detail in a minute. So first of all, there is the supply. So a lot of these are PhD positions. So here's the Talby survey, again, from 2014. That report looked over 4 years to see what the trend was in general about how many people were produced. And you can see the numbers for the things that sort of meet those demands: graphics and visualization, high performance computing, and scientific and numerical computing. The numbers of PhDs coming out in these are somewhat lower compared to all of the other disciplines. Of course, these other skills are definitely needed, but these are the specialties that relate to those positions that were hard to fill. And more recently, I think we need more artificial intelligence, and that's pretty robust in these 4 years. So that is good news. But overall, the number of PhDs being produced is somewhat low compared to the other disciplines. We can also look at the challenges here in another way. If we look at enrollment in these PhD programs by residency or ethnicity, if you see most of the people graduating overall or enrolling are non-resident aliens to the United States. That's not bad for any measure, but several of those positions in high performance computing, especially in the security focused labs, require a security clearance. So it's very hard for us to hire people that aren't native citizens. And that's probably true of anybody's national security labs or companies, right? You need to have people that can get security clearances. The other thing that's interesting in this survey is you can see there are certain segments of the population that are drastically underrepresented in this pool of people. So for example, Black or African Americans are only at 2%. That's way below the amount of the population in the United States of African Americans. We can also see that in a few of other sectors of the population. So we're missing out on an opportunity to get a whole set of ideas from people and a whole set of workforce. If you look at the data based on gender, so continuing on the demographics, the PhD enrollment is very strongly slanted to males. Females make up only about 29.5% of the people enrolling in computer science and engineering and information science PhDs. Definitely that's buoyed up by the information science, which is useful to high performance computing, but maybe not as in demand as the computer science and computer engineering disciplines. The good news on this note is that the 2021 Talby survey notes that the percentage of women enrolled in computer science and engineering programs has increased steadily over the last 6 years. So that's good that women are building into the workforce. However, reports like the National Academies of Science, Engineering, and Medicine, Transforming Trajectories of Women in Color, point out that the gains for women are not equal across all ethnicities. So again, there's a missed opportunity there for workforce, and also it just should not be like that. So if we look at the demographic data from the national labs, this is on an open website that tracks demographic hiring data for all of the national labs. It's actually put out by the national labs. We can see these trends echoed. So national labs have a huge number of students, graduate students and postdocs that work embedded. You can see at the undergraduate level, women are represented at 41%, so getting close to the 50% of the population that women make up. Underrepresented minorities is sort of this category that takes into account African Americans, Hispanic and American Indians, plus anyone else on the hiring survey that classifies themselves as an underrepresented minority. And you can see that that percentage is much higher at the undergraduate level than it is at the postdoctoral level. So echoing what we see in the Talby survey's enrollment. If we look at this as we head towards career, the technical research staff would be like the early career, and then maybe technical and line and senior leadership would be the later career. You can see that the number of women drops off to 20.19% for research engineers and technical staff. We also see a huge drop in the number of underrepresented minorities. Something else that I'll point out here, this other people of color, which in this case, for example, is Asian and Asian Americans and Pacific Islanders, the percentages are somewhat lower here. And this is reflecting the fact that a lot of the positions in the national labs do require security clearances. So we have to have native citizens in a lot of them. And that challenge might be unique to facilities in countries or industries that deal with any kind of national security. So I'm not sure that this applies to industry, but the percentages are lower there, even though this fraction of the populace would have the non-resident aliens probably represented in it. We can't hire the non-resident aliens that are getting PhDs for these security related positions. So that's one of our specific challenges. So the Department of Energy just looked back over the 40 years of OSCAR. This report came out in 2021. And some of the things about workforce that helped the department succeed at managing these extreme scale and exascale and high performance computers over the last 40 years were pointed out in this report. And the things I want to highlight here are that the Department of Energy recognized that workforce investments have been critical. So training of workers, mentoring of workers, outreach to people that are maybe in the education pipeline from levels, from high school through, or even junior high through college. Those have been critical. The other thing the report notes, as we've seen in the Talby survey and other things, is this is a very sought after workforce. So what can we do, keeping that in mind, to help with these workforce challenges? Well, another letter that came out in 2014, this was from the Advanced Scientific Computing Advisory Workforce Committee. It pointed out that the workforce gap is increasing for factors that I just talked about, and also that there's a continued underrepresentation of minorities and females in the workforce. And that's probably, both factors are going to get worse unless there is an active intervention on the part of the Department of Energy. The report also states that one of the things that really helped bring people into the specialized workforce was early exposure to the environment. So in this case, we're talking about internships and mentorships and projects in the national laboratories. And this is not unique to the Department of Energy computing laboratories, right? We can all think back to our experiences as interns and think about how that gave us fuel to be excited about the careers that we were pursuing from an early level on forward. So internships are probably one of the ways that we can help build specialized workforces in computer science and engineering. The report also recommends that the Department of Energy supply people with the educational materials that they need for these specialized areas. That's also something that probably applies to anybody that needs specialized computer science workforce. Building some sort of resource for people in undergraduate and maybe early graduate school helps people understand that that is a direction of career that they can pursue. So these are the recommendations out of the report. Well, one of the answers to that report came from the Exascale computing project. So Exascale computing project is provisioned by the Department of Energy, and its job was to supply all the needed environment software and hardware for the coming Exascale. And you can see we're actually here because the Frontier supercomputer is the first Exascale computer. It's went into operation at Oak Ridge National Lab earlier this year, and it'll be available for users early next year. So Exascale computing project also was cross-cutting. This project involved the 8 national labs that generally deal with high-performance computing in the Department of Energy national labs, and also the 3 big user facilities, Argonne Leadership Computing Facility, National Energy Research Scientific Computing Facility, and Oak Ridge Leadership Computing Facility. Those facilities are the ones that bring in all the users to the large open science machines. So there's several hundred projects at any given time running on those that represent hundreds of researchers doing high performance computing simulations and getting breakthrough science from the insight. So the Exascale computing in 2021 decided to take action on those recommendations from that 2014 report that I mentioned on the last slide and develop a broadening participation initiative or task force. So there's representation here from all of those labs. We also have people at the labs that are whose job is to focus on diversity in the labs. So this task force started, and it started to work with those recommendations. And like anything, you need to start with a good vision statement, and the task force spent a lot of time at first building a community between those 8 labs by getting to know each other and working on this vision statement. So here's the vision here. I'm not going to read it, but the idea was that the task force wanted to form a community that was supportive of everyone doing high performance computing, the workforce that might be entering high performance computing, and also the workforce that would be continuing. So retaining people that are already in this workforce. There's also a focus on making sure that underrepresented communities in high performance computing were included in the environment. So here's our mission statement: engage talented people from underrepresented groups. including those listed here. Raise awareness of the Department of Energy activities and needs. So that comes into making sure that people entering the workforce are aware of our specialized needs. Provide pathways for interaction early in people's careers and education. And then the other thing was to leverage and complement all of the broader engagement initiatives that are already going at these 8 labs. ECP was a good start for this because it already involved 8 different national labs. So it's one of the ways that you can see a model of something where you have lots of small efforts going on, trying to combine those efforts and get a bigger payoff out of it. So if there's just one slide that describes the Broadening Participation Initiative that formed out of this task force, it would be this one. There's 3 thrusts that are forming now. The high performance computing workforce development and retention action group. I lead that particular initiative. The introduction to high performance computing. This is an education initiative, and the sustainable research pathways. This is sort of a multi-pronged fellowship and mentoring program that brings students into the national labs for a research experience. And again, the unique multi-lab partnership is the reason the ECP was the place that this was piloted. We want this funding, by the way, to go beyond ECP. So we want these efforts to continue, and we're very interested in partnering with people to continue to grow efforts like this and learn from their efforts as well. But I'll detail what we're doing in our efforts so we can find areas of synergy. So the first thing we did is build on current efforts. And Marianne Leung, who is one of my co-authors of this slide deck, she started the Sustainable Horizon Institute, and it has programs that have been running since somewhere in the early teens of this century to broaden participation in computing. So Sustainable Research Pathways is one I'll talk about in a moment. She works with a lot of broadening participation at international conferences like SIAM, and she also works with several committees that cross-cut in the national labs already. So working with an already standing entity that was maybe engaging sectors of the community that might not be in the status quo high-performance computing network of the national labs was one of the things that we identified as key to being able to outreach. We also, as I said, looked at all the programs. So there's several listed here that were already going on at those labs. So part of our effort would be trying to understand the wisdom of all of these, combine them for best practices, and maybe extend those programs in places that it made sense. The idea here, again, is community building between these 8 very geographically separated across the US national labs. So the first one is the Workforce Development and Retention Action Group. That really has 3 heavy activities. One of them is the group itself meets monthly. It has representatives from all of the Department of Energy national labs, and it's ensured that it has the 8 from the Exascale computing project. We also have representatives from the universities and industry that come in and use those. So that meets monthly. Its job 1 is to make people form a community across the bonds of distance. And 2, it's to plan the next 2 thrusts. So 1 is a webinar series that tackles cultural and workforce issues that are related to workforce development and retention. And then the other is to develop a website presence that can help start bringing together all those resources that I mentioned on the previous slide and others from the community. Yeah, and this is an effort that we want to live beyond ECP. So here's some of our webinars. These are open to the public, so you can join them. If you're in a time zone that's not convenient for joining Eastern Standard Time or Pacific Coastal Time in America, these are all recorded. So just to give an example, we tackle cultural issues that affect everyone. For example, like how to be a good mentor. We tackle cultural issues about broadening participation and diversity. And skills in general. Here's another example of a skill, ally skills. This is how to be basically a good coworker and a good leader, and also to help ally for underrepresented communities, to help people feel a sense of belonging in high performance computing or whatever discipline. This fourth webinar, Black Lives Count, towards accountability and efforts to diversify computing. This is going to tackle the idea of how important it is to represent demographics accurately. But that webinar isn't until October 25th. So you can go and click on that link and register, but you won't be able to see the recording yet. So the next effort, that effort that I just mentioned kicked off in March of this year. The Intro to High Performance Computing is just getting started. So this is the effort to build a curriculum that helps bring some of those workforce gaps together and informs students about why high performance computing would be interesting for their careers. So the motivation is, one, to build on a couple of programs that we're already running and give people the needed skills to get into those programs. So here are two listed. At PESC is a summer school at Argonne, very competitive entrance. It has 2 weeks intensive focus, where students that already know a little bit of programming, like, for example, C language, and something about MPI and OpenMP, just the beginning part of that, can take their knowledge to the next level. This is targeted at early graduate school and undergrad, and even some postdocs. And then the probably most prestigious fellowship for high performance computing that the Department of Energy manages is the Computational Science Government Fellowships. This is an extremely competitive program. And it would be one of our markers of success if people that had taken this curriculum were able to go from that in undergraduate and apply for this fellowship as they're coming into their postdocs. So these are two programs that are just examples of the kind of things we want to prepare students for. The problem that we are answering is the capacity and knowledge of high performance computing, including AI, at many research institutions or universities is fairly limited. High performance computing is often an elective, and graduation requirements for computer science and engineering, or even domain science, often don't leave the bandwidth to take electives or extras like high performance computing. So Department of Energy is really in a good position to teach these courses because it's one of the Department of Energy's specialties. So this effort is going to try to pool our knowledge and build a curriculum. There's two approaches to that. One is direct to students. The national labs will have a regional Intro to High Performance Computing courses. This is sort of like that 2-week intensive course that I mentioned that Argonne runs, that would target, early career or early mid-education students. We're collaboratively currently developing a curriculum, and the materials we plan to make freely available online for the community use, for example, like when people come in for internships in the national labs, but also we want to make them available for individuals to study. So maybe we might use something like Coursera. The other approach is to go direct through universities. So that's to partner with faculty and intersect the workforce needs where they are at in the universities. So the plan starting out was to conduct listening sessions with minority serving institutions. So that would be like historically Black colleges and universities, for example. And this would help us make sure that we weren't building a program that was, by some implicit bias, not inclusive of underrepresented communities in high performance computing. And we'd also work with those faculty to implement the program so the faculty could teach it in their universities. So after about half a year of work or a little more, the direct to student approach already has a call for interest in the national labs. We've already started collecting the individual high performance computing training and outreach activities from each of those labs. And we're holding multiple listening sessions with postdocs, particularly at Argonne National Lab and Oak Ridge National Lab, because those have the two leadership computing facilities that have the most users, or the most extreme scale computing users. Actually, NERSC would also be a good place to do this, the Berkeley lab. But the object here is to talk with these postdocs who have already made it through their journey and see what their process for learning high performance computing was, and if there's anything missing. So we've definitely identified some gaps there where a lot of people did a lot of their high performance computing self-taught because they were domain scientists and didn't have resources available in their university that they could get to because of how demanding their curriculum was. And then we're collaborating with the Sustainable Horizons Institute that I mentioned earlier to build a tailored national lab focused curriculum. The Through the Universities thrust has already had its listening sessions with the minority serving institutions. So 12 institutions have already participated. Those will continue, and they're already formulating a proposal to support 2 to 4 faculty to develop high performance computing based modules to integrate into existing curricula at universities. So that makes it a little bit easier in that time crunch to put a little bit of high performance computing knowledge in the already required courses. At least that's our hope. So our last thrust, the Sustainable Research Pathways. This is a multi-lab cohort of students from underrepresented groups, and also including the faculty working with them that are collaborating with the Exascale computing teams that are trying to build scientific applications that can run on the extreme scale computers. And these ECP team scientists are going to mentor the students and faculty and help them network and build community. So this program is actually built on the Sustainable Research Pathways from the Lawrence Berkeley National Lab. This program was started in 2015, and its model is exactly what we're going to copy. So the Sustainable Research Pathways for High Performance Computing for ECP is just taking that example and extending it to all of the labs. So it's going to build on that model, to make sure it's working with students and faculty from underrepresented groups. They're strongly encouraged to apply. Everyone, though, is encouraged to apply because we want to build the workforce overall. And this will help people build interrelationships between the national labs as well as these people go on through their careers, and hopefully some of them will continue to make their careers in the national labs. So the summer 2022 was the first cohort. There were 61 participants, 13 in a student-only track, and then 16 in a faculty track where faculty came into the lab as well, and they brought 29 students with them. These were all funded by the Exascale computing program, but there was also an option for students that had independent funding to come and just participate in the program, which had lots of activities for students. For example, we taught students how to give posters, how to write papers, how to give a lightning talk to introduce themselves at a conference, or how to give a lightning introduction of their work. So there were many successful projects. So far, several of them are continuing to give posters at ongoing conferences. So 3 so far will be presenting at the Supercomputing Conference. It's sort of a big deal in high performance computing, happens in November. All of these students went through the matching process that was actually developed at Berkeley. They just extended it to the lab, so you can see the matches there. So this is starting to already build a very nice interlab community that also includes mentoring students. So some of the other features of the Sustainable Research Pathways, there was a pre-internship onboarding where some of those activities that I talked about were done. Summer internship, students were given opportunities to present posters at the ECB conferences, and there was a lot of community building. The next phase is starting now, so be looking for it. I imagine it will be linked somewhere on the Sustainable Horizons page. If you want to see the highlights from 2022, there's the link, and probably this will be one of the places that 2023 is announced. But now we're using a multi-lab program spanning the ECP labs, but other computational and data science projects that are coordinated through our Computational Research Leadership Council, which includes most of the ECP labs, will be invited this year as well. So we're hoping to expand that program. Again, this is another program that we want to keep building on and find a way to continue it beyond the Exascale computing program as that starts to wind down, as the Exascale machines start to come into production through the national labs. I guess in conclusion, the Exascale Computing Broadening Participation Initiative has a really solid start. Its 3 thrusts are going. We want to continue to partner and learn from other people that are doing these kinds of activities, both in the US and outside the US. We'd like to extend the 3 thrusts beyond the Exascale Computing project. And we want to acknowledge that there is an importance and urgency for Department of Energy high performance computing workforce challenges, as I've outlined in this talk. I hope those examples were also useful to you if you are not in the national labs. And the other thing I want to say is we have to do more. This was an example of 8 individual Department of Energy labs coming together to have a concerted effort. But the problem of building this workforce is much bigger than even any particular set of institutions or country. So it's very important for all of us to try to work to build these workforce programs and reach out to the generations of students that are coming into this workforce and let them know about the specialties we need and give them the information and expertise that they need to choose our disciplines. So thank you very much. I know that I am recorded, and I would certainly love the chance to take your questions and talk to you after the fact when it's actually daylight over here where I'm living. So thank you so much for this opportunity. If you want to see the references that I used, here they are. And I also want to acknowledge the Exascale Computing Project for funding the development of these materials. Thank you very much.